All right, ladies and gentlemen, here it comes at you full force, the product rule. We're going to let f of x be a function that could be thought of as the product of two other functions, u of x, and we'll change this to v of x, where we're saying that this u of x and v of x are differentiable functions. Let's find the derivative. So our derivative is equal to the limit, h goes to 0, of f of x plus h minus f of x. So this is going to be u x plus h times v x plus h minus u of x v of x, all divided by h. Oh boy, where do we go from here? Well, we're going to do some mathematical magic, if you will. We're going to do something without really doing anything. In other words, we're going to add 0. Can we all agree that the part I'm subtracting in red is really nothing? So I'm doing something without really doing anything. And now I'm going to group these terms in a very specific way. So I'm going to take the terms that have ux plus h and group them together, which allows me to factor the ux plus h out. And then we're going to add the rest, and we're going to do it similarly. Try to take these other two terms and get them grouped and displayed similarly to what I have in the yellow box. My hope is that you came up with something such as this. Now, we can use our properties of limits again. We can take the limit of the first thing plus limit of the second thing, which gives us this. And now we can use another property of limits, which says that we can take the limit of each thing that we're multiplying together. So we get the following. And now let's take the limits of these things. Limit as h goes to 0 of u of x plus h becomes u of x times, you guys better be on the ball with this, this next piece is v prime of x. That's the derivative of v with respect to x. That's the definition of derivative. Plus v of x times, that's the definition of derivative again, this time for u of x. So when we differentiated this, u of x times v of x, the derivative, we get this. And here it is written in all of its glory. If y is equal to u times v, then y prime is equal to u times v prime plus v times u prime, where u and v are functions of x. There are two other ways of writing this down below. But what you need to know for the product rule is if we have a function that is the product of two other functions of x, we're going to do first times derivative of the second plus second term times derivative of the first. And this is just something you need to know and get familiar with. You don't have time to go through this process every time you need to figure out how to differentiate a product. If you want to, go for it. But I really, really would not recommend deriving this each time. This is a rule that, guys, you just got to know. And on that note, let's do some problems. So, f prime of x is going to be first times derivative of the second. What's the derivative of the second term? Well, the derivative of the second term is negative 3. Plus second thing times derivative of the first. So the derivative of the first is just 2. And really, we could leave it this way, but if it's just asking us to find the derivative, and we have something simple like some distributing and combining like terms, like we have in this problem, we really need to finish this off and simplify. So our derivative is negative 12x minus 1. And recognize that we could have taken f of x and FOILed, expanded that out, and then used the power rule on each term to come up with this very same derivative, but knowing these rules to differentiate will make very complicated functions much, much simpler and more fun to differentiate. Example 2. Find the equation of the tangent to the curve y equals x squared plus 1 over x plus 1 at 0, 1. Ooh. Wait a minute, that's not two things multiplied together, is it, guys? Well, as you might have guessed, we probably can write it as two things multiplied together. This y is actually equal to x squared plus 1 times x plus 1 to the negative first. So our first thing that we're multiplying is there in the green box. The second thing we're multiplying is there in the black box. So now we go ahead and we're going to use our quotient rule. So now we're going to go ahead and use our product rule. First times derivative of the second. Okay, derivative of the second, careful, this one requires the chain rule. Times negative 1, x plus 1 to the negative 2, times the derivative of what's inside, but nicely the derivative of what's inside is 1, plus second times derivative of the first. Derivative of the first is 2x. And isn't this thing beautiful? You might be saying, well, no, not really. It's not terrifically beautiful, like you say, but that's okay. This is the derivative. This can be simplified. We could say that the derivative is equal to x squared plus 2x minus 1 over x plus 1 squared. And I challenge you to try to get there algebraically, but having it this way is sufficient for what we need to do. It's okay if you leave it there. So this is our f prime of x. We need the equation of the tangent. Well, what do we just do this for? Oh yeah, this gives us the slope of the tangent at a given point. So what we need is the slope when x is equal to 0. So we plug zeros in. 0 squared plus 1 times negative 1 times 0 plus 1 to the negative 2 times 1 plus 0 plus 1 to the negative first times 2 times 0. And if we go through and deal with all of this simple arithmetic, we find that the slope at x equals 0 is negative 1, and we can now write the equation of our line, y minus y1 equals m times x minus x1, and rearranging we get y equals negative 1x plus 1. And there's the equation for our tangent line. In the next video, we will go through something known as the quotient rule.